First, we'll look at how we modify a part using traditional history-based parametric techniques. As we can see, a series of features were used in order to build up this model. If we want to modify the main arm in some way, we need to identify the feature or features that constructed it in order to edit them. Here we can see that the model's history rolls back to that point in time and displays the feature's parameters. If we dig a little bit deeper, we can see that due to the constraints in its profile, we can only modify its length and end radius. If we want to make any different changes, we will need to change the way in which it is constrained to give us more freedom, as we can see here. Adding a linear or an aligned dimension will once again allow us to control the length. Now, if we dynamically edit the feature, we can see that we have more ways in which to edit the shape. Notice, however, the slowest response as we drag, due to the fact that Solid Edge needs to be continuously recalculating the history of the model. Now let's try and move the cone-shaped surface upwards. Since we don't know how the complete model was constructed, it is necessary to play back the history in order to give us some idea of what will happen as we make a change. Reducing the height of the first extrusion will move the cone shape up as desired. However, it will also reduce the height of the model too, since the other features were built on top of each other, as we can see here. As such, in order to fix things, we need to make another edit to increase the height of the part, as shown here. However, this now means that our shorter arms may be in the wrong place, and a further edit needs to be made to these. As you can see, even on this relatively simple model, we need to be mindful about the way it is constructed in order to ensure that changes are easy to implement. Please review the next video which shows the same process of edits, but using Solid Edge's synchronous methods.